everybody, in this video we're going to be looking at correlation. So I have some data sets here that are sort of comparing two different types of data. So this first one we have a homework score and an exam score for several different students. So we have this first person got 75% for their homework score and their exam score was a 68%. Now I just totally made up this data as an example. We could certainly do the same thing for data for our class, but I just wanted to give us some numbers to look at. So what we can do is take this data and graph it together, and I'm going to use the calculator to do this. So we want to go into the Stat button and then into Edit like we've done before to enter data. Now in this case we have two lists of data, so I'm going to enter all of the homework scores into list 1 and then all of the exam scores into list 2. So for list 1 we've got, I'll go ahead and enter all these in. You can enter them in on your own and just pause the video and come back when you're done. Alright, once you've got them all entered in, make sure that they line up so that you didn't accidentally forget one or add an extra in either list. Then we're going to graph these together. So I'm going to use the second button and then y equals. You'll see above that there's a little thing in yellow that says stat plot, and that's what we want. So we're going to use plot 1, although you could use any of them. So I'm going to select plot 1 and I'm just going to turn it on. The rest of the settings, assuming that you haven't changed them in the past, should work just fine. So we're using this little icon that has little dots on it for a scatter plot. And then our X and Y are going to come from list 1 and list 2. Now you could change these if you wanted to graph different data, if you wanted to use list 3, list 4, etc. And then we can also change what mark we're going to use for the data values. I'm just going to stick with the little square. Now, if you go to the graph right now, you probably won't see anything. If your graph is set on the standard viewing window, which is -10 to 10 in both the X and Y directions, then the problem is that all of these data values are bigger than 10. So we're not going to see anything if we just graph it on this window. So one option you could do is to set the X min and max, Y min and max yourself using the window button. So if we wanted to do that, we would say, okay, well, what X values do we have? Our X values are the homework scores, so maybe I could have them go from 0 to 100. Those are the only possible scores we could have. And then same thing for the Ys, 0 to 100. And that's a good way to get exactly the values that we're interested in. Another option, so let me go to the graph, we can take a look at this. So here are our data values plotted on the scale. Another option that you can do that's a little quicker is if you go to the zoom menu, you can go all the way down to this one, zoom stat. And what that'll do is look at the data values in your table that you entered in and just pick a window that would work for that. Now I don't like this window quite as much. It's giving us a few negative X values on the left here, which is fine, but it's cutting off the Y values just below the lowest one. So this gives us kind of a false picture that our Y values, which were our test scores, that they're really low. But really it's not going that far down. It's just that the window they choose, the minimum for the Y is 40. So I'm actually going to stick with 0 to 100 on this. I think that gives us a little bit better of a picture. All right, and we see from this that we have some high homework and high test scores here. There's a couple of points over here that are low homework scores but fairly high test scores, and then some in the middle. So this would be an example of some data that isn't really that well correlated. And correlated means that essentially the data falls in a line. Now we might have predicted that if you had a really low homework score you would have a low test score, and a really high homework score would have a high test score. And we see that a little bit here, but if that was really the case we would expect the scores to be sort of lined up in a diagonal, and that's just not what we're seeing here. So one thing we're going to look at with data and correlation is if we have some data put together, we can run what's called a regression. So what this looks like on the calculator is if you go to the home screen, so you can quit out of the graph, second mode button, and then I'm going to go into the stat menu and select over to the calc menu. Remember, this is where we found how to compute mean, median, and mode, that kind of thing. And I'm going to go down to this option number 4, lin reg. This is linear regression. This is essentially finding line of best fit, and we'll talk a little bit more about that in the next video. But in particular, I'm interested in this value R. So this particular set of data, our R value is 0.680. And this is a fairly low R value. We'll look at the range of R values in just a second. But this indicates to me that there's low correlation between homework scores and test scores, at least according to these data points that we put in. Now in comparison, let's look at the second example. For diamonds, the weight of the diamond, and that's in carats, versus the price of the diamond. Now we would expect that a heavier diamond or a larger diamond will generally sell for a larger price. So there should actually be some amount of correlation here, but we can see what that looks like. So again, I'm going to go into my stat menu, into edit, and I'm going to use the list 1 and list 2 to enter this data. Now I'll go up and highlight the title of the list and press clear, and that'll get rid of my data. So clear and then enter. I'll go up for list 1, clear, enter, and then I'll go ahead and enter this data. Once you've got that data entered in, let's go ahead and run the regression. So I'm going to quit back to the home screen. I'm going to do the stat button, over to calculate menu, and then go down to the linear regression option number 4. All right, here you see that the R value we're getting is 0.952 about. This is a much better regression value, or R value. This means that there is a pretty high correlation between a diamond's weight and its price. Now one comment, if you are doing this regression option and you're not seeing the R or R squared, if it's just telling you A and B, then what you want to do is go into the catalog, and you'll only have to do this once. So you're doing the second button, and then catalog is right above the 0. So second, catalog. And there's a whole bunch of functions in here. If you find the button that has a D written on it in green, this is the x to the -1 button on my calculator, you can jump down to the D options, and you want to go through and pick diagnostic on. So if you select that and just press enter, it'll say done, and then go ahead and run your regression again, and you should see the R and R squared values show up. So you only have to do that once, and then it'll just keep giving you those values each time you use the lin reg option. All right, so this data we're seeing has a pretty high correlation. If we actually look at the graph, and again, if I go straight to the graph, I'm not going to see anything here because this is not a good window for the types of values we're picking. You could try the zoom stat option, or I'm going to go straight to the window and say, okay, well, what range of values do I want for my x's? Now my x's here were the carat weights, and these are really small numbers. So I'm going to go from 0 to, our largest value is 1, so I'll go to 1.5 just to be sure. And then the y values are our prices. This would be in dollars, and these go up to, looks like the highest one is about 5,000. So I'll go from 0, I'll go up to 6,000. And I'm just trying to get these to match what kind of values we're going to be looking at. So if we graph, we can see that lower x values, meaning lower weights, have low prices, and then as our x values go up, the prices go up. Now the slope of this line is pretty steep, meaning that, you know, a little change in our carat weight is going to have a strong change in price, which shouldn't be too surprising based upon diamond values. But we can see that these sort of form a pattern, they form a line better than the score values that we were looking at before. So when we're looking at correlation, I wanted to show you some picture examples. We're comparing two pieces of data, and seeing how they line up. Now, a perfect correlation would mean that the values were exactly in line, sort of like this picture on the left here, or this picture on the right. We can have either positive or negative correlation, depending upon whether the slope is positive or the slope is negative. But then, as the data gets more spread out, it has less and less correlation. So in the middle here, we have an R value of 0. This would be absolutely no correlation. The data is just sort of scattered randomly. There's really no relationship between our X values and our Y values, or our two different data sets. As the R value gets really close to 1 or really close to -1, we have stronger correlation. So here's a graph example looking at the number of hours studied, I believe for a test, versus the grade on the test. So as we see, if you have very few hours studied, the grade is low, higher hours studied, high. This would be a strong positive correlation. We see here that the R is 0.89, which is pretty close to 1. So we would say that there's a strong correlation between the number of hours you studied and your grade. We can also have strong negative correlation. And here's sort of an amusing example from this same website. This is the grade on the test and the number of beers drank. So again, this is a fairly strong correlation, not quite as strong as the first one, but it's negative, indicating that drinking more beers before your test would have a lower grade rather than a higher grade. So in terms of the graph, this would just represent a negative slope instead of a positive slope. Now, we see correlation all the time in statistics. This was just a quick news search I did on Google for correlation. And we can see some interesting articles here. There's a correlation between what music you listen to and intelligence, correlation in prices for coal and oil. In business, there's a lot of correlation talked about. There's a few articles in here about the S&P 500 and stock prices. Here's an article about correlation between GPA and gym usage. This is looking at a correlation between different diseases and GMO foods. So we would have to investigate these topics more, but this is sort of suggesting some sort of link between two different data types. And the main piece of information we're interested in this section is this correlation coefficient, which is R. And like I've already mentioned, R is a number, it ranges between -1 and 1, -1 and 1 being perfect correlation, either positive or negative. And then if R equals 0 right in the center, there's absolutely no correlation. So we're looking for a high value of R, either close to 1 or close to -1, to say that there's correlation. Now, your book goes through how to compute R by hand, but I don't need you guys to do that. We're just going to get the R value from the calculator in this regression readout. So don't worry about going through the calculations by hand. One thing we have to be careful with when we talk about correlation is the difference between correlation and causation. Correlation means that there's some sort of relationship between two types of data, but it doesn't necessarily mean that one is causing the other. So for some of these examples that we looked at, so for example, if you drink 15 beers the night before your test, it would kind of make sense that that would cause a lower grade. Or for example, we might expect that the number of hours studied would increase your grade. But that's not necessarily the case. For example, someone who studies a lot might just be a stronger student in general, so that might be increasing their grade more so than actually the number of hours studied itself. Another example here is a correlation between having a tutor for a class and having lower test scores. Now this is a little counterintuitive. We would think that if you had a tutor, they would help raise your test scores. And that's likely the case, but if you think about it, the people who get tutors tend to be people who have lower test scores in general. So it's not that having a tutor is causing you to have a lower test score. It's just that there's sort of a third factor, an outside relationship that would link having a tutor with potentially having a lower test score. Here's another interesting example from this this website here, Spurious Correlations. Here they have a graph, and this is not a scatter plot like we've been looking at, but it's looking as a function of time, U.S. spending on science, space, and technology, and suicides by hanging, strangulation, and suffocation. So we could look at the data table here. Now the correlation here, this would be the R value, is 0.99. This would indicate a very strong correlation between spending and suicides. But does that mean that somehow the U.S. spending more on science is increasing the number of suicides? Well, probably not, and we wouldn't really expect that to be the case. There's likely some other factors going on here. So this could just be a function of time. Also, our population has been increasing quite a bit, which could explain the increase in suicides just as a number. We might be more interested in looking at a percentage, right? For example, what percentage of suicides are by hanging or strangulation, or what percentage of the population has these suicides. And same thing, U.S. spending. Spending tends to go up in general just due to inflation and rising prices. So even though there's a very strong correlation here, we have to be careful about what does that really mean. Another thing to think about when we're looking at correlation is the effect of outliers. So I have a little picture example here. Right down here at the bottom, there's just a whole bunch of data values kind of clustered around. And then over here we have a very strong outlier. Now if you think about what would happen if we did a regression on this, because we have sort of this implied line through the center, this outlier out here is sort of giving us the impression that this data is somewhat correlated. So this data set would have not necessarily a high R value, but an R value that suggests some amount of correlation. However, if we ignored that outlier and looked only at these values down here, so if we just threw out this extra data point, if we were only looking at this, we would say, no, there really isn't any correlation. These data values are just spread all over the place. They're not forming a line. So in this case, with outlier, we might say that there is some correlation, but without the outlier, there's no correlation. So we have to be a little bit careful that we're not letting the presence of just one or two strong outliers affect our judgments. And another thing to keep in mind is that there are plenty of examples of data that are related to one another, but not necessarily in a linear relationship. So when we talk about correlation, we're looking at either positive linear correlation or negative linear correlation, depending upon whether we have a positive or negative slope. But there are other types of relationships. So for example, here I have a graph looking at anxiety and test performance. And there has been research, I of course just sketched in this graph here, but there's research that says that some amount of anxiety is actually good for test performance because it makes you a little more on task. But if you have very high anxiety, then that of course is going to make it hard to perform well on tests. So if we looked at this data, we might see that a little anxiety towards the middle might increase test performance, but then test performance would drop off. This is for following more of a quadratic equation, and there are other ways we can look at quadratic relationships or exponential relationships and things like that that we're just not going to look at in this class. So this particular data would not have very strong correlation in terms of a line, but if we were able to look at it in terms of a quadratic, that would be a much better fit. I wanted to throw this comic in here. This is the comic XKCD. I have this one on my office door. All right, so here's the problem for you to try. All I want you to do is use your calculator to look at this data. This is looking at PSAT scores and SAT scores, and see, what is the correlation coefficient, and does that mean that there is correlation or isn't? Sort of what could we conclude. In the next video, we're going to be looking a little more at what can we do about deciding whether something correlates or not, and then what can we do with that.